Today I'm going to show you a quick overview of how the navigation system of ROS works. So I'm going to give you a high view of all the components that are required in order to make a robot navigate on an unknown environment. So this is a question that I see being asked many times, and looks like people doesn't understand the different parts that the navigation packages of ROS contain. So, and also, for example, I have seen this question that ROS answered a couple of days ago about providing some guidance about how to navigate on an environment while avoiding obstacles. Okay, so this question is answered by using the ROS navigation stack. And that's what we are going to see here. Just a simple example, okay? I'm not going to go into the details because it's a lot of work. But you will see how it should work, a navigation system. So, great. So, first thing, let me use a simulation here on the ROS Development Studio that you can access at any time by visiting rds.theconstructsim.com. And I'm going to launch this simulation. It contains interesting environments for navigation. So let me launch it. Here, let's select one of the launch files. I'm going to select this one, a specific circuit, and run it. Great. So this simulation has been created specifically to work with OpenAI, and that's not the case of today. Today we are not going to work with OpenAI, but with ROS navigation. But just in case that you want to work with OpenAI and Gazebo and ROS together, that's the perfect way to start. We have some other videos explaining how to use this OpenAI system here in the RDS, in the ROS Development Studio. But today we are not going to use it, so I'm going to close it. And here we have the simulation that has been loaded. Let me show you the whole environment. Is this one. Here we have the robot, the environment. So the first thing that we need to do in order to make navigate a robot in an environment like this one is to create a map of the environment. For that, we are going to use a node provided by ROS that it's called the gmapping node. With the gmapping node, we can create a map of the environment. How do we do that? Well, we are going to launch the gmapping by launching this command here. It's just specifically create a gmapping configuration for the TileTelbot that you can check. If you come here to the RDS, you can check that launch file and what it contains, how it's being configured. So we launch it, and then the gmapping starts to work. So it starts to create the map. So two things here. First, we need to move the robot around in order to make it learn the whole environment, create a map of the whole environment. Second, we need to see how this map is being created, because here on the screen with the text is very ugly. For seeing what is happening, we are going to use the RBIS. So let me open a new terminal here, and then let's launch the RBIS. Rosrun, RBIS, and here it goes. In the RDS, in order to see the graphical tools of ROS, we need to use this icon here. This will open a new tab, and press login, and then I will connect to the screen where RBIS is here. So what can we see here? So I have a specifically prepared RBIS configuration file so you can see everything. First, we see the robot here. This is the robot. Then in red are the lectures of the laser scan that this robot has, because we are using a laser to create the map. So the robot doing navigation, usually it will use a laser to create the map. And then we have this gray area. This is the map that the robot has created so far. So this is the area that the robot here can see from his point of view. So this is the area that can see, this area here, this area here. So that's what he has included here on the map. Now, what we are going to do is to move the robot around and see how this map is being built, but it remains there. For that, let me just detach here, so we can see everything at the same time. So let's put it a bit smaller, and here on top. Let's put it on top. And now we need also to move the robot. We need to move the robot with the keys. For that, I need to launch another ROS program, so I need another shell. Let's open here. And the command for the turtlebot is ROS launch turtlebot teleop keyboard teleop. Right, this is the program that controls the robot using the keys. So I'm going to put it also detached on this beneath the RBIS, so we can see everything at the same time. Great. Okay, so now first I'm going to decrease a little bit the speeds, because I know that this robot, it starts moving very fast. So let me decrease the speeds here. Okay, so here looks like we had a disconnection. Yeah, no problem. This is due to the quality of the network. I'm currently connected, so don't worry, everything restores by itself. Great, so we have here the keyboard teleop, so I'm going to move it. What you will see is that the robot here moves around, and at the same time the map here is being built. So let's go for it. So let me move it a little bit, turning, moving. Let me decrease still a little bit the speed of rotating. So here I'm moving. And as you can see also in RBIS, the robot is also here. It's also moving here. It's representing the position where the robot is while creating the map. So here I go. Let's increase a little bit the speed. Okay, so here it goes. Then I'm going to turn. Yeah, I'm sorry that I'm not very good at moving the robot around, but yeah, I miss my days of Xbox. I was studying robotics, so I didn't have time for that. And yeah, but so far so good, yes. And as you can see on the RBIS screen, you can see that it's on top of the screen, on top right, that the map is being built as I move the robot around. Yep. And here we have the whole map, almost, because it remains the small corner over there. So we are watching it now from this position, so it will be included here. Great, we have the map created. So this is the whole map of this environment. Then next step is to save the map. This map has been created. Now we have to save it in order to use it later for localization or path planning. So how do we do that? Well, we need to launch another command. In this case, I don't need anymore the keyboard, so I'm going to just stop the keyboard, and I'm going to launch the command that is the one that saves the current map that is being represented here on RBIS. Okay, so let's close this, and also, so yeah, so no, sorry, I didn't have to close, so let me open it again. And yes, so I'm going to launch the command that saves the map, and here it is map server -f with the name of the map. So I'm going to save it with my map dot, no, sorry, just my map, like this. Okay, great. So now if we check, the system has created those two files, my map pgm and my map jam. Those are the files that describe the current map that has been created. Great, so now we have the map done. Because the map has been done, then this program that was running here about doing the map, this is the gmapping node, then this one can also be stopped because we don't need it anymore. Now, so then what we need, the next step is to localize the robot inside that map. For that, we need to launch the localization node. So the next step is that we are going to localize the robot and move the robot around that map, autonomously, I mean. So for that, we need three things. First thing, we need the map server. The map server is the one that uses the map that we have just created. So it's the one that provides to any other node the map that we have created. So we need to launch that one. Second, we need to launch the localization stuff. It's the node that decides where in this map the robot is at present. And third, we have to launch the move base. The move base is the node that makes the robot move around that map when the robot wants to go from one place to another, creating paths and avoiding obstacles. So for that, I have prepared a specific launch file, and which content is the following. You can check it on this direction. So we have here ROS-cd in Turtlebot. Is in Turtlebot, Turtlebot navigation gazebo. Here on the launch, here we have one that it's called move base demo, and this is the one that I'm going to open, move base demo. So you can see, let me move a little bit this up. So here you can see that there are the three things that I have said. First, it launches the map server that provides the map. Then second, it launches the localization system. And third, it launches the move base. Okay, so how to those specific launch files for those specific nodes should be done and configured. That's another matter that I'm going to discuss here today. But you can have a look at those files if you want by accessing the ROS Development Studio. So great. So then let's launch it. And it's ROS launch, Turtlebot navigation gazebo, move base demo launch, but also we have to provide with the location for the map file. So I have to provide a parameter that is called the map file, and a map file is at home user my map. It is because I have saved my map at this location, at my at home user is where I save it on the here. Yes, so it's let me reconnect that here, directory. So here it is, home user. Yes. Okay, great. So I have it here. Yes, specified everything. Then I'm going to launch this whole localization and path planning and move base nodes, everything together. Great, so it's been created. Now here on Harvest you can see that the robot now it appears in a very random position and location. Yeah, this is normal. This is due to the new start of the localization node. And the robot starts localized in a random position. Now we have to, what we should do is to indicate to this program, to the localization program, what is the current position of the robot. So we can see it here. It's more or less on this corner, looking into that direction. So that will be around here, looking into that direction. For that, we press the 2D pose estimate. And we select more or less the position. So you do a click and then drag in the direction that you think that the robot should be looking at and drop. Okay, more or less. So far, you can try as many times as you want, so in order to make it better, but it's not necessary to have it very precisely, because then afterwards the localization system will correct these errors while the robot is moving. Great. So now if the robot is localized on this map, so it says, oh, in the real environment here, I am in this position in relation to this map. So now you can start sending goals to the robot. For example, let's say here. There it goes. And you can see as in the RBase it goes, and then of course in the simulation, then it also works. If you had a real robot instead of the simulation, then it will send the commands to the real robot. So let's provide another place to go. For example, here. There it goes. And so far so good. So yeah, you can say, yeah, go here. For example, at the end of the here, go here. Then there it goes. Yeah, sometimes it happens. Yes, but here, there it is. It recovered completely. So that's it. Basically, that's the way. So you first create a map, you save the map, and then you use that map for localization and path planning. Okay, so basically that's it. So this is the end of. Okay, so basically that's it. I've shown you how to launch all the required system to do a navigation system. If you need more detail, then you need to learn how the navigation stack works. For that, of course, I recommend you to learn using the Robot Ignite Academy. I will put the link below, but there is a specific course explaining all the configuration parameters, how you have to do in order to use that for your robot, step by step, with many examples, and of course with many exercises on the simulations that you have online. You don't have to install anything, and you can use any computer for doing those courses, of course. Then try that, subscribe to our channel, and press the bell so you will get notified when we publish more videos like this one. So thank you very much for your attention. Bye. In Robot Ignite Academy, you will find a lot of courses about ROS using your web browser only. You only require that. You don't need to install anything, and you can use any type of computer because everything is web-based. So we have many courses related to different programming of different ROS-based robots, specific for beginners, like introduction for ROS in 5 days, but specifically for this question about ROS navigation, we have this course, ROS navigation in 5 days, which contains a lot of details about how to configure the ROS navigation stack for mapping, for localization, path planning, obstacle avoidance, and even how to use so the navigation in a couple of projects, a Turtlebot project and navigation. So just give it a try at robotigniteacademy.com.